Okay, so now for question 3. It's a normal distribution, so you'll need your tables for this one, and it says the mean. Now I use x bar for the mean, but you could use other letters. So x bar is equal to 253, and the standard deviation is 5. So determine the probability that x is less than 250. Now I always draw a diagram. You must draw a diagram because it really helps you. So if you draw a rough diagram like that, the mean is 253. Standard deviation is 5. And I want the probability that x is less than 250. So I want that area there. So I need to standardize this 250, and there's a formula for this: x minus x bar, all divided by standard deviation. So if I do 250 minus 253 divided by 5, I get the z score for that, and that would be minus 0.6 minus 0.6. Now, if that was a positive number, I'd just look it up in my tables, but unfortunately it's not. I can't look up a negative number in my table, so I need to use the properties of the normal to use the symmetry of the graph. So if this is 0.6, then this corresponds to exactly the same area as I require up here. So I can look 0.6 up in my tables, but the probability, the problem is that the tables actually give you the probability it's less than. So the tables are going to give me that probability there. So I need to do 1 minus. So I'll do 1 minus the probability that z is less than 0.6. So you crack your tables out, look up z is less than 0.6, it's 0.72575, take that away from 1 and to 3 decimal places, you're going to get 0.274. That's part AI. That's part AI. For part AII, they've been quite helpful here, using the same value, so you don't need to re-standardize that. It's going to be the same z score for that. So again, it's imperative that you draw a diagram to see what you're dealing with. So there's our 253, our mean. Now I'm looking for the probability that x is between 245 and 250. So I'm looking for this area here. Okay. So I've just looked up what it would be if it was less than 250. So all I need to do is take this off my answer to part I. I need to take this bit here off my answer to part I. So I need to look up what the probability that x is less than 245 would be. So first of all, standardize this 245. So 245 minus 250 divided by your standard deviation, which is still 5, gives you a z score of minus 1.6. Minus 1.6. So if I look up my minus 1.6 in the table, I can't because it's a minus. So exactly like I did on the first one, I have to use the symmetrical properties of the normal distribution to look up 1.6. Now, if I look at 1.6, I get 0.94520, but that's actually this, and I don't want this. I want this one. So I need to do 1 minus 0.94520 for this one here, which gives you 0.0548. So that means this area here is 0.0548. So we take our answer to part AI, which is the whole of that area, okay, and we subtract 0.0548 from that. So my answer to part AI, subtract my answer, and I get 0.219 to 3 decimal places. Part A, III, only worth 1 mark. It's a very quick thing, this. When you're doing normal, the probability that's exactly equal to 245 is 0. Actually, the probability it's exactly anything is 0. Okay, so I'll just rub that out. Okay, so only part B now. It's with 4 marks. It's a little bit tougher than part A, but it says assuming that the value of the mean remains unchanged. So sorry about that. So I know that the mean stays as 253. Determine the value of the standard deviation, so that's what is now not 5, to ensure that 98% contain more than 245. So there's my 245, and I need the area above that to be 0.98, 98%. So I need to find that standard deviation that would give me that to be 0.98. Okay, so what's happened here is that when this 245 has been standardized, minus 253 over the standard deviation that I don't know, it's given us a z-score that would correspond to that area being 0.98. So that's what we need to look up. Now, if you look at the smaller of the two normal tables, again, it always gives you less than. So really the way you need to think about it is if this area is 0.98, what z-score will that give you? So if you look up 0.98 in your smaller table, it'll give you a z-score of minus 2.0537. And then you have to use the symmetrical properties of the graph to say that the z-score, oh sorry, messed up there. That should be plus 2.0537. So now you use the symmetrical properties of your graph to say that the z-score here should be minus 2.0537. So you just change it from being a positive to a negative. So this thing here must have been equal to minus 2.0537, and that now allows us to calculate that missing standard deviation. So 245 minus 253 divided by this standard deviation must have given me minus 2.0537, and I can quickly just rearrange that, multiply by the standard deviation, divide by minus 2.0537, and I should get standard deviation to be 3.902, 3 significant figures.